Our story begins with a bang, the Big Bang. Imagine everything squeezed into a tiny point smaller than a pinhead. Suddenly it exploded. The universe was born. Space expanded rapidly, getting bigger and bigger. As the universe cooled, tiny particles started to clump together. These clumps grew bigger and bigger, forming giant balls of hot gas. These were the first stars, enormous furnaces blazing with light and heat. Stars are like giant power plants, creating new elements in their cores. These stars lived for millions and millions of years. Eventually, many of them exploded, flinging their stardust far out into space. This stardust, full of new elements, would become the building blocks for planets, moons, and even you and me. About 4.6 billion years ago, a giant cloud of stardust and gas floated in space. This cloud, called a nebula, was left over from the explosions of ancient stars. Something disturbed this peaceful cloud, perhaps the shockwave from a nearby exploding star. This disturbance caused the cloud to collapse in on itself. As it collapsed, it began to spin faster and faster, like a spinning figure skater pulling in their arms. The spinning motion flattened the cloud into a swirling disk of dust and gas. At the center of this disk, the material clumped together, growing hotter and denser. Eventually, the pressure and heat became so intense that a star was born, our very own sun. While the sun blazed at the center of the disk, the remaining dust and gas continued to swirl around it. Tiny particles collided with each other, sticking together like cosmic dust bunnies. Over millions of years, these clumps grew larger, pulled together by gravity. They became planetesimals, the building blocks of planets. In the inner part of the disk, where the sun's heat was strongest, rocky planetesimals formed. One of these rocky planetesimals, destined to become our Earth, continued to attract more and more material. As it grew larger, its gravity became stronger, pulling in even more debris. This process, called accretion, is how Earth grew to its present size. Section 4. A layered world. The early Earth was a hot and violent place. The constant bombardment of planetesimals generated immense heat, melting the young planet's surface. Denser materials like iron and nickel sank towards the center, forming Earth's core. Lighter materials like silicon and oxygen rose to the surface, creating a thin crust. Between the core and the crust, a layer of molten rock called the mantle formed. The Earth's interior was like a giant furnace, with heat and pressure constantly churning the molten rock. The Earth's surface was a sea of molten rock dotted with erupting volcanoes. Over time, the surface began to cool, forming the first solid rocks. This process of melting, cooling, and solidifying would shape Earth's surface for billions of years to come. Section 5. Water, air, and the breath of life. The early Earth had no atmosphere as we know it. Gases trapped within the planet's interior escaped through volcanic eruptions, creating a thin, toxic atmosphere. But something remarkable happened. Water appeared. Where did this water come from? Some scientists believe that icy comets and asteroids, remnants from the early solar system, bombarded the young Earth, delivering vast amounts of water. As Earth cooled, this water vapor condensed, forming the first oceans. The early atmosphere was still very different from the air we breathe today. It lacked oxygen and was rich in carbon dioxide and other gases. But over time, primitive life forms would emerge in the oceans, forever changing the Earth's atmosphere. Section 6. Life finds a foothold. The appearance of life on Earth is perhaps the most remarkable chapter in our planet's story. In the primordial soup of the early oceans, a remarkable transformation took place. Simple organic molecules, perhaps delivered by meteorites or formed through chemical reactions, began to self-assemble. Over millions of years, these molecules became more complex, eventually forming the building blocks of life: proteins, DNA, and RNA. The first life forms were single-celled organisms, similar to bacteria, that thrived in the harsh conditions of the early Earth. These early organisms possessed a remarkable ability. They could convert sunlight into energy through photosynthesis. This process released oxygen into the atmosphere, slowly transforming it into the air we breathe today. Life had taken hold on Earth and would forever alter the destiny of our planet.